Okay, so now that we've used the power rule and we've learned that and found the derivative of a constant, we are now going to look at the constant multiple rule. So let's take a look at these functions. We have f of x equals 3x squared, f of x equals 10 times the square root of x, f of x equals 1/2 x to the negative 1/2. How do we find the derivative of these functions? In other words, remember, the derivative is an equation which, when you plug an x value in, gives you the slope of the tangent line. So how could we do that with these functions? These are a little bit different because they have constants. They have coefficients out front. So that's where the constant multiple rule comes in. I'm going to show you a proof. So basically, we're just going to define g of x, a function, equal to f of x, but times a constant. So basically, c is the coefficient of some particular function, f of x. So c could be 3, it could be 1/2, it could be 10, -2, whatever. So let's go ahead and use the definition of the derivative to prove this. We know that the definition of the derivative of g would just be g prime of x equals the limit as h approaches 0 of g of x plus h minus g of x over h. Now, we want to figure out what g of x plus h is. We define g of x to be c times f of x. So g of x plus h would be c times f of x plus h. So we're going to replace g of x plus h with c times f of x plus h. And of course, g of x equals c times f of x. So it will be replaced with c times f of x. Now, right off the bat, you can pretty much tell these both have a c in common, right? So we can pull a c out of both of these top terms, which precisely we're going to do. When we pull it out, we're going to just put it out in front of the function. Now, the reality is, the limit as h approaches 0 of all of this stuff, c is going to do nothing more than multiply that. And so we can actually just take the c and pull it outside of the limit. We've learned this before when we did limits of, basically when you have a constant times a function, you can pull the constant out. So this goes back to our limit laws. Now that we have the c outside of the function, we can rewrite all of this as just f prime of x, right? Because this gives us the derivative of f. This is the definition of f prime of x, so we can replace f prime of x. So we've just proven that given g of x equals c times f of x, the derivative of g is just c times f prime of x. What does that mean? That means we can just simply take the derivative of f, and then whatever we get, we will multiply it by the original constant, hence the constant multiple rule. It's really easy. In other words, you kind of put the c off to the side, you find the derivative of the function in front, or next to it, and then you multiply the original c by that derivative. So let's go ahead and apply that rule. Say we have f of x equals 4 times x cubed. So, how are we applying the constant multiple rule? Well, the function in this case is x cubed. The constant multiplying it is 4. That's how we're going to implement the constant multiple rule. Make that a little bit bigger for some of you, maybe can't see it. All right. So basically, we can split this up into 4 times x squared. According to the constant multiple rule, we can find the derivative of this and then just multiply that by 4. Okay. And again, step 2 for this entire series on derivatives of polynomials is to identify which rule you're using. In this case, we're using the constant multiple rule. We're also using the power rule because our function is actually x squared. So we're using both rules. So step 3, we're going to take the derivative. Now, what we can do basically is just move the 4 out and then take the derivative of x cubed. Whatever we get, we will multiply that by 4. We've already proven that the derivative of x cubed is 3x squared. Take the 3, move it out front, subtract 1 from the exponent. And final step is just take that original constant, multiply by your derivative. Final derivative is 12x squared. F prime of x equals x squared. So we've proven that the derivative of 4x cubed is equal to 12x squared. Pretty simple, right? I want to show you one more constant multiple rule. I'm going to have to kind of tell you what the derivative of sine is for now, because you haven't learned it yet, but it's important that we see a function that's different than a polynomial, just so you can get the gist of this. So we have f of x equals negative 5 sine of x. I want to figure out what f prime of x is. Although we haven't proven it yet, I can go ahead and tell you that the derivative of sine is cosine. So just remember that, derivative of sine is cosine. So when we convert to a familiar form, we see that we do have a constant number multiplying a function, so we can use the constant multiple rule. Okay, so that's the rule we're going to use, the constant multiple rule. So right off the bat, what we can do is we can take the derivative of sine, right, and then whatever we get we can multiply by -5, but we just showed that the derivative of sine is cosine. If we multiply that by the original constant, we get -5 cosine of x. So we've just proven that the derivative of -5 sine of x, the original, let's go back, the derivative of -5 sine of x is just equal to -5 cosine of x. In other words, just take the derivative of the function and multiply by the original constant. So that's it. That's the constant multiple rule. It's very simple. If you have any other questions about the constant multiple rule, let me know.